In this demo, we're going to talk about fuel trims, basically what they are, how they respond to changes in airflow and fuel configuration, how the ECU uses them, and then how you can use them to make adjustments to your own fueling and airflow setup. The first thing you need to understand is there are two modes of operation in the ECU with regard to fueling. One is called open loop, the other is closed loop. In an open loop system, there is no feedback, so the system just assumes whatever it's doing is producing the desired result, and it doesn't bother checking up on itself. We can see that in an ECU by locking it in open loop mode, which I'm going to do here, and then starting a data log. And you can see the front O2 sensor, which is the ECU's main feedback mechanism for closed loop operation. You can see it's staying flat. The ECU is not making any adjustments to its fueling at all. It's just running blindly, basically. A closed loop system is where there is some feedback mechanism, and the system is allowed to make adjustments to its assumptions to get things running the way it's supposed to be. We can see that by turning closed loop back on and going back to our data log. And you can see now the ECU has switched into closed loop mode and has started cycling the O2 sensor. So basically the ECU is taking a, you can think of it as a knob, and turning it one way to richen the mixture and turning it another way to lean it out to make the O2 sensor cycle like this. That knob is what we call fuel trim. It's a trim to the basic fuel calculation inside the ECU, and the ECU can just crank that knob one way or the other to make the O2 oscillate. And you can see it in the log here. I'm going to stop the log for a second. The O2 sensor, when it's low, the factory O2 sensor, that indicates a lean mixture. So the ECU saw the O2 sensor went low, and you can see this is the fuel trim variable here. At that point, the ECU started increasing the fuel trim variable to a positive direction. Basically, it was adding fuel at that point until the O2 sensor cycled up, indicating a rich mixture, and then the ECU switched to leaning it out by lowering the fuel trim until it switched lean again, and it just kept doing it back and forth. And that's how the ECU works with fuel trim. It's just moving it up and down. And you'll see it's averaging in my car about 1.2%. So on average, the ECU is adding about 1.2% of fuel over what it thought it needed based on airflow and its idea of the injector size and dead time. Fuel trim is nice in that it tells us something about the system's configuration, how well it's matched, but it could also be a little misleading because everything could be either dialed in correctly or everything could be dialed in wrong, but just happen to be dialed in a way that cancels each other out. So it's kind of hard sometimes to know exactly what to adjust when your fuel trim's not right. So what you do is you kind of pick something that you know should be at a known value and you hold that steady, and then you can adjust the other things. For example, at idle, we would expect airflow per rev on a 2-liter engine, fully warmed up on a manual transmission. We'd expect airflow per rev to be about 0.25. This car, you can see I'm running 0.28, 0.29, so I'm running a little high on the airflow per rev. So I'm going to adjust that using the MAF compensation tab. Now, this is a table of adjustments to the airflow curve based on the MAF frequency coming into the ECU. You can see the MAF frequency in your data log by looking at MAF raw. We can see I'm idling about 30 to 35 hertz or so, which means I'm going to adjust these first two fields here. And airflow per rev was 0.29. We want about 0.25 or so. So I'm going to take these down about 8 or 9%. And because I don't like a big jump like this from one cell to the next, I'm going to go and I'm going to kind of smooth that out a little bit. There we go. And then I'm going to hit Save to ECU. Now what's going to happen is we're going to suddenly change the ECU's idea of airflow. So when we do that, we're reducing the airflow reading coming into the ECU by as much as 9%. So that's going to suddenly cause a lean mixture, and let's see what happens. Alright, so let's go to the data log now. And you can see when I save that change, suddenly the O2 sensor went lean. The ECU saw the O2 sensor went lean and started cranking up the fuel trim. So now we're up at about 12% of adjustment. But we know our airflow per rev is more correct now. So we can leave airflow alone and we can switch off to fuel flow now. At idle, the main thing you're going to deal with in fuel flow is the dead time. Global fuel is very important. You want to make sure that's set correctly for your injector size and your base fuel pressure. So once you've got that set correctly, you're going to have to leave it alone and assume it's right for now, and then we can adjust that later with wide open throttle pulls. But at idle, the main thing that affects the mixture is your dead time. So the dead time of an injector is, when you increase this value, the ECU is going to basically increase the injector pulse width by that amount. So adding dead time basically adds fuel to the mixture in this case. So if we go back here, and again we still see 0.25, 0.26 on the airflow per rev, so that's close enough. And we know combined fuel trim is positive, so the ECU had to add fuel to correct its base fuel calculation. So we're going to go over here and we're going to add fuel as well. And I'm going to click that box so that the changes are saved to the ECU automatically as soon as I make them. So this is kind of like dialing the injectors in real time. I'm going to add we'll add about 100 microseconds. We'll go back to our data log and see the effect. And now you see what happened. We added fuel, so we changed the mixture. It got a lot richer. The ECU saw that and started pulling fuel with the combined fuel trim until it started cycling again. And now we're at a much better position here. That's perfectly fine. Fuel trim's around 0.1% or so. So at this point we've got the idle dialed in, which means we've got our dead time and our airflow per rev dialed in at idle. So the next thing we're going to want to do is go grab a cruise log. Now the problem with cruise is that you're going to get a lot more airflow variation. We're pretty stable here at 35 hertz. When you cruise, you're going to see a lot more variation as you go up and down hills and through flat sections. So it would be kind of tedious to have to track all of those changes for the airflow table. If we go back to the airflow table here, you've got all these different points, and you'd have to basically average the combined fuel trim for all those different points and then move them into the airflow table. But what we've got in ECMLINK is a tool that does that for you called the Map Comp Adjust tool. We have a similar one for speed density, but we're going to focus on the mass airflow for now. We'll cover speed density in a later one. The Map Comp tool basically does just what I said. It tracks the MAF raw variable as you're driving around and averages combined fuel trim for each of those buckets basically, and then moves that into your airflow table for you. To use that tool, you're going to have to make sure you have a few things captured in your logs. To show that, I'm going to have to stop the stream for a minute and then pull up the captured values dialog. You're going to want to make sure you have combined fuel trim, the closed loop indicator, and then MAF raw, which I have here. You already see it's bold-faced. I've already got all these things logged, so I'm just going to hit OK. If you don't have them, you need to add them to your ECU first. All right. The other thing that I want to mention about this tool before we get to the data is that because we're asking the ECU to calculate combined fuel trim for us over a variety of conditions, we'd like to tell the ECU to stay in closed loop for as long as we can. You can adjust the thresholds that the ECU uses to determine when it switches in and out of closed loop in the open loop thresholds table. These are basically load factors, airflow per rev. It's kind of equivalent to boost, where if you exceed this value, for example, 0.85 for load factor at 2500 RPM, the ECU will switch out of closed loop and stop tracking combined fuel trim. We want to bump these values up a good bit. So I'm going to take these and I'm going to select all of them here, and I'm going to, I want to set them all to about 1.1, 1.15, something like that. A value of 1 is about atmospheric, and then when you get above that, you start building some boost. So I'm not going to go too far above it. I'm going to set them all to the same value by first zeroing them and then running it back up. And as soon as that's done here, there we go, that's good enough. I'm going to right-click and do Copy Table, and I'm going to paste that table up here. So we got a copy of it in our delayed threshold. You can read more about these down here, but basically that's just, it's a different version of this table where you have to exceed that value for 20 seconds before it switches. And then this is the throttle position. If I give it more than 36% throttle at 2500 RPM, it's going to switch into open loop. I'm going to do the same idea here. I'm going to set them all to about 50%, just so I know it's not going to switch into open loop until I'm really starting to get on it. And that'll give me some more closed loop data for my dial-in. Alright, so with those changes made now, we're going to stay in closed loop mode for a longer period of time, and we're going to collect more data from the ECU, which is exactly what we want to do. When we're done, we can use this button here to reset all those values back to stock values. So we don't have to down or anything. We can just let the application do that for us. Alright, so we're ready to go grab that cruise log. Now, in order to make this demo work right, I've already done that cruise log, so I'm just going to open the file here. And you can see there's a lot of, this is the combined fuel trim again. So we got a lot of different combined fuel trim values. I can tell there's some good adjustment it's going to make to my table for me. And with this log now, I can right-click and do Map Adjust, Combined Fuel Trim. And it's going to make a number of suggestions to my airflow curve for me. That's what these little white circles are. These are the suggested values based on combined fuel trim as I was driving around. The yellow values here, those are the current values. So these are the current values that we changed just a minute ago, and then these are the suggested values. If I click Use Template, it's going to copy those values in as my current values. I don't like this one a little bit. So this is the point where you go through there and you kind of smooth it out a little bit. This point looks a little abnormal to me, so I'm going to smooth it out a little bit. I know that we've also made some changes to this one already, so I'm just going to bump it up a little bit. And since this one's a little more negative than it was before, I'm going to bump this one up a little more positive, so the average between them, which is where we are at idle, ends up about the same. So now I've got a table here of adjustments. I might go ahead and take this one up a little bit more too. Just your goal here is to just kind of smooth that table out a little bit, and then hit Copy to ECU. And so now we've made those changes. They've been saved to the ECU. We can do a data log here and see where we are. We're still in that 2-3%. That's perfectly fine. Airflow per rev still perfectly normal, 24, 25. So if I want to, I can tweak this a little more by going into the Fuel tab, because again, our airflow per rev is okay, so we know any adjustments we need at this point are going to be to the dead time. Maybe I'll bump it up one more, and then go see the results. Yeah, you could use a little bit more maybe. So you get the idea though. You basically play around with that and get it dialed in where it's working, and then you're done. You know, you're set. The next step then would be to take some wide open throttle data and dial that in, but we're going to do that in a different demo because wide open throttle really has nothing to do with fuel trims, because the ECU locks itself in open loop at wide open throttle, so we'll cover that in a different demo. For now, I think that's about it for the fuel trim. Hope it was useful.